First of all, we will open the workbench, then we will double click on the model and we right click on the geometry and we open the new design modeler geometry. So we're waiting a few seconds for it to run. So after we open the design modeler, we choose the SY plane, then we look at the face and make sure our unit is in meter. Then we sketch the rectangle, which is our mesh 1. For the dimension, we will choose the semi-automatic. Then for the L1 is our dimension of X of the mesh 1, which is 0.5032. This one also 0.5032. Then for the H3 is 0.5032 divided by 2, which is 0.2516. This one also 0.2516. Then we will extrude it and then we apply on sketch 1. Direction we choose the both symmetry. This one the diff 0.2516 and we will generate. And this, as you can see, this is our mesh 1. For the mesh 2, in the same XY plane, we will click on the new sketch here. The new sketch is sketch 2. We will sketch a rectangle for the mesh 2, then the dimension also semi-automatic. Here we will choose the horizontal, then we will click on the vertical for the length here, and now we will define the length. This one is the 0.5760, which is the dimension of X for mesh 2. This one also. Then this one is the 0.576 divided by 2, which is 0.2880 meter. This one we choose 0.576, then we will extrude it, apply on sketch 2. Direction will be the both symmetry. This one is 0.288. Then we will generate and it will become 2 cube. This one is the mesh 1, this one is the mesh 2. So we got 2 cube here, mesh 1, mesh 2. Now we will open back the workbench. So we open back the workbench and right click on the model and click edit, and we're waiting for it to run. So after we open the model, we will make sure the units first is meter. So we will continue for the materials, make sure it is the structural steel. Then for the connection, we will insert the spring. So the first spring is 200 kN per meter. This one we put the body to the ground. So the reference we will put negative 0.716. This one the scoop we will choose. Scoop we will choose here and we apply. Then you can see there is one spring. Then connection also we insert the second spring, which the stiffness is 400 kN per meter. So the scope is body to body. So we will choose the scope here and here. Choose the scope, apply. Then another scope is this one, apply. Then you can see the second spring. For the third one, we also insert the third spring. Then this one, for the longitudinal stiffness is 600 kN per meter. So this one will be the body to the ground again. Then for the scope, we'll be choosing here and apply. This one I think, the third one, the reference X will be 2 meter. Then it will become on the here. So we have spring 1, 2 and 3. This is 200 kN per meter, 400 kN per meter and 600 kN per meter. So now we will right click on model, insert the remote displacement. We will choose on this face, apply. Then since X is moving, the another value will be 0. Then we right click on model again, insert again the remote displacement on the mesh 2. So we apply, then the rest also 0 except the X only. Then the analysis setting will be 2. Now we will right click on the model F5 and solve. So we will waiting for it to run. Then we will see the solution here, and this is our frequency. So this is the first design, the frequency for the first design. For the second design, we will open back the spring and change all the value of the spring stiffness to 200 kN per meter. Then the third one also 200 kN per meter. Then we right click the model A5 and we will solve. Then we will wait for it to solve. So as you can see, the frequency now is changed to 1.9937 and 3.5929 for the frequency of the second design. So to get the omega, we will using the omega equal to 2 pi f to get the omega for both of the design.